Let's jump right into this explainer. We're going to completely transform your Git experience today, taking it from a terrifying minefield into a robust, forgiving safety net. Whether you're a seasoned developer or you're just kind of finding your footing, we're going to unlock some tools that will absolutely change how you interact with your code. Okay, picture this incredibly relatable scenario. You run a command, maybe a hard reset or a rebase, and you just watch hours of hard work seemingly vanish into thin air. You're sitting there, staring at your screen, totally convinced you've done something unrecoverable. Trust me, we have all been there. So here's our roadmap for building your advanced efficiency toolkit. First up, fixing your last commit. Second, the reflog safety net. Third, managing your workspace. Fourth, multitasking with work trees. And finally, peeking under the hood. Now, obviously, Git is an immensely powerful version control system. It is the backbone of modern software development. But today, we're focusing specifically on advanced rescue and efficiency commands that every single developer needs. We're moving way beyond the basics to give you absolute control over your project's history. All right, Section 1, fixing your last commit. Let's start with the most common everyday mistake. You realize you made a typo or forgot a crucial file literally right after hitting enter. The git commit-amend command fixes this. Think of amending as just replacing your old commit with a brand new one. It functions exactly like editing an unread text message right after you send it. If the other person hasn't seen it yet, you can fix your typo and they are none the wiser. But here is the absolute golden rule of amending. It's completely safe for local, unpushed work. If it's just on your machine, go wild. But it becomes incredibly dangerous once you've pushed that commit to a shared repository, because amending actually replaces the commit. Doing it after sharing creates conflicting histories for your teammates, and that forces them to deal with some pretty complicated merge issues. So assuming you haven't pushed, you have a lot of power here. You can easily fix a message typo using the M flag. Or let's say you forgot to stage a file. You can stage it and cleanly add it to the last commit, without changing the message at all, just by using the -no-edit flag. And if you run it without any flags, it just opens your default text editor for more interactive, detailed fixes. It's really a fantastic way to keep your local history clean and professional. Moving on to Section 2, reflog, the ultimate safety net. So how do we handle a slightly more terrifying scenario, like a dreaded rebase gone wrong or a hard reset that wiped out an hour of your life? Well, Git's best-kept secret is Git reflog. It's your local safety journal. Basically, it acts as a black box recorder that silently logs every single time your head pointer moves. Every commit, every checkout, every reset, Git is secretly recording it locally. It keeps those quote-unquote deleted commits perfectly safe until the garbage collector runs weeks later. When disaster strikes, here is your exact recovery workflow. Step 1, run Git reflog, and don't touch anything else. Step 2, look through the diary output and locate the hash from right before the disaster struck. Step 3, do a git reset hard to that specific hash. This instantly rewinds your repository state back to safety. Boom, everything you thought was lost is instantly back. To put this into perspective, one developer in our sources noted that discovering this simple 30-second recovery process for a botched 40-minute rebase completely removed their fear of experimenting. Seriously, once you know the reflog is there watching your back, Git stops feeling like a minefield, and it actually starts feeling like a sandbox. Okay, Section 3, managing your Git workspace. Now that you know you can recover from almost anything, the best way to handle a disaster is to organize your uncommitted workspace to prevent it in the first place. We've all been here, the mid-refactor hotfix emergency. You're in the middle of a massive, messy refactoring session, broken code everywhere, and suddenly your boss demands an immediate, urgent fix on the main branch. What on earth do you do with your messy workspace? Enter Git stash. This command safely puts your uncommitted changes away temporarily, giving you a totally clean slate so you can switch contexts without making a messy work-in-progress commit. And here's a great pro tip from the developer community. You can even use the -p flag with stash. This lets you interactively step through your code and stash specific changes piece by piece before you switch over to tackle that urgent bug. What if your workspace is just cluttered with untracked files or directories you want to get rid of entirely? For that, you use git clean. But a huge word of warning here. Git clean is a destructive, irreversible command. Always use the -n or dry run flag first. That previews what's going to be deleted. Only when you are absolutely sure should you use the -F flag to force deletion or the -D flag to remove untracked directories. This brings us to Section 4, multitasking with Git work trees. So what if your workspace is in such total disarray that even stashing feels too risky for an emergency hotfix? This is where you bring out the heavy artillery, Git work tree add. Instead of stashing, this absolute superpower associates a completely new working tree with your repository. It literally allows you to have multiple branches checked out simultaneously in entirely different folders. Basically, work trees let you jump into parallel dimensions. You create a link directory, check out a new branch, fix the bug, push it, and then clean it up with Git worktree remove, all without ever touching your messy refactor directory. And because they share the exact same underlying .git folder, any commits you make in the worktree are instantly recognized by your main repository. It's a real game changer. Finally, Section 5, peeking under the hood. As we wrap up this toolkit, let's take a quick look at the underlying mechanisms that make all these high-level commands possible. You're definitely familiar with the standard commands seen on cheat sheets, things like add, commit, switch, and rebase. In Git terminology, these friendly tools are called porcelain commands. But beneath the surface, Git relies on hidden, internal plumbing utilities to actually process the information you're feeding it. One of the most critical plumbing commands is git rev parse. Think of it as parse a committish to a full SHA-1 hash. It essentially acts as the underlying engine that translates or massages a friendly branch name or a tag into the exact, unambiguous 40-character SHA-1 hash that Git's internal scripts actually need to function. It's the silent translator making your everyday commands work seamlessly. So, what does this all mean for you? Next time a commit vanishes, or you get hit with a mid-refactor emergency, just take a breath. Open your new toolkit. Ask yourself, how quickly can I rescue this using the reflock? Should I stash this or spin up a work tree? Think about it. How much time and honestly, how much stress will these rescue and efficiency commands save you in your very next sprint? Go ahead and experiment fearlessly. You now have the safety net to catch you.